Hi, we're looking at section 3.5. Oops, sorry, a little high. 3.5, completing the square. And we're going to walk through what I mean by that. And what is this? This is going to be a method for solving quadratics. All right, so what I mean by solving by quadratics is finding the x-intercepts. Okay, and we're going to start out with one you already know. Let's say I have the equation y equals x squared minus 4. Well, what we want to do is we want to make this equal to 0. Because y is 0 on the x-axis, and we're trying to find where this parabola crosses the x-axis, so we make it equal to 0, and we do that every single time. And if we notice here b is equal to 0, and I've told you in the past what you're going to do is bring that c to the other side, so I'm going to add 4 and I'm going to have x squared. And I'm going to take the square root of both sides, and the square root of 4 is 2, but because I'm squaring this value over here, I can have a positive 2 or a negative 2, and that equals x. And this, if we take a look at this x squared right here is called a square. And the idea is that geometrically, if you had a square and this length would be x, this length also would be x, its area inside is x squared. And that's where the term this being a square is from, or coming from the second power. And so a negative 2 times negative 2 gives me 4, and 4 minus 4 is 0. And 2 times 2 is 4, and 4 minus 4 is 0. So this parabola would cross the x-axis both at 2 and a negative 2. So let's take a look at another one. And I'm going to write it in this form. So, and the book will give you something that looks like this. X squared equals 7. Again, you're going to take the square root of both sides. And on the left side, I'm going to get x. And over here, I'm going to get plus or minus. That will always be the case. And we're going to have the square root of 7. Now, 7 is not a perfect square, nor can it be simplified. So this is my answer. And I have two roots, or two solutions, or two x-intercepts, one being the square root of 7, the positive square root of 7, and the other one being a negative square root of 7. All right? So now I'm going to make it a little bit more complex. And my square is going to look like this. I'm going to have x minus 1 squared is equal to 4. All right? So literally what I'm going to do is I'm going to take the square root of this side, and I'm going to have plus or minus the square root of this side. So I'm just writing this out to show you that's an operation I'm doing on both sides. I'm taking the square root on the left side, and I'm taking the square root on the right side. This is going to leave me with x minus 1. In other words, these two operations are inverses of each other, and they basically cancel each other out. So I'm left with x minus 1, and over here I'm going to have plus or minus, now listen to how I say it, plus or minus 2. Now I want to figure out what my solution is, so I'm going to add 1 to both sides. I'll write that plus 1 here, and I'm going to write that plus 1 here. And what that looks like is 1 plus or minus 2. And that really means I have two things that are going on. I have 1 plus 2, which is 3, and I have 1 minus 2, which is a negative 1. Now, if you remember, my problem was this: x minus x minus 1 squared equals 4. Well, if I put 3 in here, I would have 3 minus 1 squared. 3 minus 1 is 2. 2 squared is 4. So that works. And if I put a negative 1 in there, I'd have a negative 1 minus 1 squared. Well, negative 1 minus 1 is a negative 2. And if I square that, I get 4. So both 3 and a negative 1 are my x-intercepts. They're the solutions to this equation. They're where the parabola crosses the x-axis. All right. Now I'm going to do another one. And my next one is going to be x plus 2. That quantity, that's what we say when we put in parentheses and square it, is equal to 7. Now again, I'm going to take the square root of both sides. Over here I'm going to have plus or minus the square root, if you remember that from before. And I'm going to have x plus 2 is equal to plus or minus the square root of 7. And you can put that in your calculator and actually come up with a decimal representation of that. I'm going to subtract 2. Now, I can't subtract the 2 from inside the radical. The minus 2 has to stay outside the radical. So x is going to be a negative 2 plus or minus the square root of 7. And this is going to give me a negative 2 plus the square root of 7 and negative 2 minus the square root of 7. And you can put those in your calculators and come up with a decimal representation, but I'm going to leave them exact, and these are my two solutions. In other words, in this parabola, this is where the parabola would cross the x-axis. All right. Now, I want to talk a little bit more about this. Initially, if you take a look, I had this x minus 1 squared equals 7. This portion right here is called a binomial square. And the reason it's called a binomial square is I'm taking a binomial and I'm raising it to the second power. Well, if you recall, a binomial square can be written in this fashion. It's that value, that quantity, times itself. And I can FOIL this. And I can get this solution. X squared minus 2x plus 1. So this statement I have here is equivalent to the statement x squared minus 2x plus 1 is equal to 7. They're exactly the same. And over here, let me give you another one. This one I had before where it was x plus 2 squared is equal to 7. This is my binomial square. And I can write that as a trinomial by taking x plus 2 times x plus 2. And I get x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4. And that's what x plus 2, that quantity squared, is. This is called a binomial square. These three things are called a trinomial square. And this trinomial square is equivalent, is exactly the same as x plus 2, the quantity squared. All right. Likewise, when I had x minus 1, that binomial square, it is equal to x squared minus 2x plus 1. This would be the trinomial square for that binomial square. Now, let's take a look at some things. There's kind of a pattern here. If you notice, when I had x minus 1 squared, and I multiplied it out, I got an x squared minus 1x. But I have two of those, don't I? I have an inner and an outer, plus this 1. If you recall, the in was equal to a negative 1x, and the out was equal to a negative 1x. They were the same value. So I can double them. In other words, I could rewrite this if I wanted. X squared plus 2 times that negative 1x, since there's two of them, plus 1. Likewise, when I had this x plus 2, the quantity squared, I could say I had x squared plus, I had two of these, 2x's plus 4. All right? So if I had something like this, x plus 3 squared, I could say I have x squared plus 2 3x's plus 9. Outer, last, here are my two inners, my inside and my outside. So this would be the same as x squared plus 6x plus 9. All right? Well, let me continue on with this. Let's say I gave you something like this. X squared minus 6x plus, and I'm telling you that this thing right here is a trinomial square. What would C be? Well, you know this came from 2 times a negative 3x. So my last term and my first term, when I multiply, so I know this. Let me write out something here. This had to be a minus 3, right? Because a minus 3 times x is a minus 3x, and there had to be two of them. So this also had to be a minus 3, because I needed to get this right here. So in other words, when I multiply these two, I'm going to get 9. So I just completed the square by taking half of this b term and squaring it. Let's look at another. Let's say I have this, x squared plus 10x plus this. Well, I'm going to take 10, take half of it, and square it. Well, half of 10 is 5. 5 squared is 25. In other words, this is the same as x plus 5, the quantity squared. These are the same expression. X squared minus 22x plus blank. Well, I'm going to take a negative 22, take half of it, square it. This gives me a negative 11. If I square negative 11, I get 121. That's equivalent to a binomial of, what's half of a negative 22? It's a negative 11. These are the same thing. If I multiply this out, I get x squared minus 11x plus 121. There's my trinomial square. Right? Let me try one more. Well, actually, I'm going to try two examples here. Plus something x plus 100. Well, what would I do here? I would take the square root of 100. I get 10. And I have to multiply 10 by 2. So I'm going to get 20 here. So this is equal to x plus 10, the quantity squared. Let me check. That means x plus 10 times x plus 10. And I get x squared plus 10x plus 10x plus 100. And lo and behold, there's my trinomial square. Let me try this one. X squared minus blank x plus 49. Well, the square root of 49 is equal to 7. I take 7, I multiply it by 2, and I get 14. So 14 goes in here. All right? Okay. That's the first part on completing the square.